Hi guys, welcome to this short video where we're going to have a look at the idea of division when it comes to working in JavaScript. Now, most of the other mathematical stuff you sometimes need to do, like addition, subtraction and multiplication, pretty much like what you do normally in maths anyway, and those sort of problems normally aren't that difficult as long as we understand some basic maths. But division can be a little bit more problematic at times. So we're going to have a look at the three different ways that division can occur. And so let's start off with just jumping through to this little screen here. Okay, so when you're doing division, let's have a look at a problem where we might have to do a simple question like 5 divided by 4. Now, one thing you have to appreciate straight away is that this symbol here for division is something you can't type into your computer. So in your computer you might be typing this. Well, this actually is what I would call the normal division. So we might have a line of our code which says something like answer, or ANS, equal to this. And of course, if we're making this for the first time, we might have to put a var in front. We do need to put that. Now, if we then printed this, or the equivalent in JavaScript of going console.log ANS, should have semicolons there, what we would see pretty much is, I'll just put here as a comment, the two slashes are a comment. Okay, what we would see is 1.25, and that's all good. That's the normal kind of division. But sometimes you might have a situation where you're only interested in, well, what is the whole number of times, say this number 4 can go into 5, and I'm not really interested in what the leftover bit is. So for example, we might be sharing out some money. Let's say we were sharing out $210 coins. Okay, and we're going to share that out amongst, say, 7 people. Now this kind of division here, okay, in fact 7 was probably a poor choice because the answer to this would be exactly 30. There wouldn't be any leftover bit. But what happens if our problem had been we want to share out 212 coins amongst 7 people? Well, the answer is going to be still 30, and there's going to be a bit left over. Okay, that bit left over would be the extra 2 coins. Okay, so we could say the answer is 30 and 2/7 mathematically, but really if I'm sharing out $212 coins amongst 7 people, all I really want to know is that each of them are going to get 30 and there was $2 coins left over. So how would we do that kind of division where I just want to get the 30 bit for a start? Well, this is sometimes called integer division. You might recall in maths that integers are numbers like -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and onwards, and also downwards this way. They're numbers that don't have any fractional bits to them. Okay, so in this kind of division here, we don't have any of the leftover bits. So how do we achieve that? Well, in JavaScript, the only way to really achieve that is to use a maths property, and it sounds a little weird, but this is the way it goes. It's math.floor if you're dealing with positive numbers, and you use math.ceil for ceiling if you're using negative numbers. And I think we really need to have a look at an example to see what the heck I'm talking about here. Okay, so let's make a simple program. This is the same one that's on page 23. Okay, so we're going to say, right, let's say var result, and we're going to go equal to math dot floor, and let's go 5 divided by 4, and what will the result for that be? Well, the result is just 1. Okay, so where did that happen? Well, we know that the integer result that we got before was 1.25. What this math.floor effectively does is to round down to the nearest whole number. Okay, or to basically, not round down, it cuts off any fractional bit. Okay, so you're only taking the whole number part here. That's what that math.floor does. Okay, so we're just left with the one part. Any fractional bit cuts straight off, leaving this part here. Okay, so another example might be if we said var result 1 equal to, let's do math.floor again. Okay, and if we said this 212 divided by 7, well, I know that the whole number result is going to be equal to 30 with a bit left over, so what will this give? This will give the 30. So it was 30 and 2/7, okay, as some sort of decimal, which I can't exactly recall at the moment what 2/7 is as a decimal, but that doesn't matter. Okay, let's cut that off, leaving only the 30. So that's what that math.floor is doing. Okay, so what's this weird thing math.ceiling? Well, if you're dealing with negative numbers, and let's take a look at this situation here, where we might have result 3, and let's do math.floor. Let's go with a negative number, -5 divided by 4, semicolon. Well, if you do that, the answer as a decimal is -1.25. Okay, and that's all good. Okay, so what happens here is that when you use this, if you use math.floor on this, what effectively it does is it pushes it down to the next lowest negative number, and you actually get -2 as your answer. Okay, so that's what math.floor is doing. It's basically pushing your result downwards to the nearest whole integer. Okay, to be more accurate to what I was saying before. Okay, and we don't want that here. I want the result -1. So I want to know how many whole times 4 goes into -5. Well, it goes in -1 whole times. So this is what math.ceil will do when you're dealing with negative numbers. So if we go math.ceil and we go -5 divided by 4, okay, well, math.ceil will push it upwards to the nearest integer, which is -1. You think upwards, how can -1 be upwards? Well, if you think about -2, -1.25, and -1, -1 is actually bigger than -1.25. So ceil, when you're dealing with negative numbers again, will push it upwards, and when you're dealing with negative numbers, the floor part push it down. In fact, that's not true just for negative numbers, that's true for all numbers. But here, especially for negative numbers, if I want to know the number of whole times that 4 goes into negative 5, I want the result negative 1, I'm going to have to use math.cln. So that's negative 1 is my answer. Okay, so this was integer division. Normally, when you're just working with positive numbers, not a problem, just use math.floor to see how many whole times one number goes into another. If you are dealing with negative numbers though, you're going to have to use math.ceil to get the correct answer. Okay, so integer division essentially gives us how many whole times one thing goes into another. Now you may be wondering, hey, what happens if I want to know the leftover bit? So if I really wanted to know, for example, that 4 goes into 5 once and there's 1 left over, okay, how do I get that 1? Well, this is called remainder division, and let's swap to a new page here. Well, I call it remainder division. Okay, so let's take that same example we just had a moment ago. Okay, we know that mathematically that 4 goes into 5 1 whole times, and there's 1 left over. Okay, we can see that diagrammatically. If we had 5 counters and we wanted to know how many times 4 goes into that, well, 4 would take up that number of them, and there would be 1 left over. Okay, so how do I get this 1? Well, the way that you do that in JavaScript and a number of other languages is to use this symbol here. You think, well, that's percentage, isn't it? Not always, at least not in some programming languages like JavaScript and also Python and some others. So if we, for example, said, right, let's call this var result, I don't know what we got up to, was it 4 or 5? Let's call this 5, result 5, equal to, and we did that, well, our answer is going to be a 1, but it's not the math.floor result, this is the leftover. I suppose we could show that more obviously if we said, right, let's do result 6, and we said, right, let's do 5 divided by 3. How many whole times does 3 go into 5? Once, but the leftover is 2. So that's what we're going to get here. Okay, so there are the 3 kinds of division then. Okay, normal division, integer, we use math.floor usually, or sometimes math.ceil, and this remainder division, where this, let's call a percentage symbol, isn't used for a percentage here, it's used to actually calculate for us what's left over. Right, let's swap out and go to an actual practical problem. Okay, so let's just change the pointer here, and let's go to the desktop. Okay, so this is looking at page 23 of your book I gave you the other day, last Friday. Please read over this page here, but let's swap over to the next page down, okay, and read that top part there as well. I'm going to have a look at these 2 problems here. Try this exercise, and then we'll have a look at problem 13. Okay, now try this exercise one here. What's this about? Well, this one here, we've got, just reading it through with you, a band of 14 buskers, people that play sometimes on the street for money. Okay, and they have managed to get together $161 coins. It's people throwing money into the hat. So we want to share that out evenly, and we want to know how much is left over. Maybe that goes into the pool, and then the following day when they're busking again, once it gets over the 14, they can start to share it out evenly again. Alright, so we want to write expressions to determine how many coins they will have to turn into smaller change. Well, I'm not sure about that. Okay, it was basically how many coins left over, and then how many each busker is going to get. So we're going to, I think, if you think about that one, the method will be how many whole times will 14 go into 161, and then we want to know how many coins left over, and that, they say here, are the ones that we're going to turn into smaller change. Okay, well, we could turn into smaller change, or we could just put into the kitty, like I said, and keep it for the following week. Alright, so how do we do that? Well, I'm just going to swap straight over and have a look at a solution that I've already done for this one, and then we'll try and do a solution for the next one here from scratch. So here we are, well, there we are, inside JavaScript. Let me try and get that working, there we go, and minimize that, get that out of the way. Okay, so here is a program that I've written. Okay, now you may be wondering, what's this console.clear? Well, this is a way that you can clear out this console area on each run of your program, so you're not getting one run, then another, and then so on. Okay, so you might want to use that, console.clear. Now, I'm making up two variables here. I've decided to call the 161 as the number of coins, so I've called that num coins. The number of buskers, so num buskers 14, and basically two things I want to calculate. How many coins were left over? Okay, so I've called that num coins left over. Okay, now you could abbreviate that a little bit, but make sure your variable names are descriptive. So I've got var num coins left over equal to, so the number of coins, and here's this integer division. Sorry, not integer division, the leftover remainder division. So we're going to see how many whole number of coins are left over. Okay, and so that's the number of coins divided by the number of buskers, but it's the remainder division, so that's going to be the number of coins left over. Okay, now this next part here, see if you can pick up on a possible error here, okay, which I have deliberately left in here. Okay, this is the amount each will get. Okay, so this is the whole number of coins each is meant to get. Well, I'll call that amount each. So I've just done the normal division here. Num coins divided by num buskers. Okay, now I'm consoling.log each of those things. Okay, so amount each and the number of coins left over. You may be wondering what this bit here is. This is a way in which you can round a number to a fixed number of decimal places. So dot to fixed, notice the camel case there is important. The lowercase 2, the uppercase fixed, all one word, no spaces, and then in brackets what you're rounding to. Now I've already run that before, but let's run it again, and here's the result over here. The amount each busker gets is $11.50. Number of coins left over is 7. Well, we're dividing up whole dollar coins, so how can they be getting 50 cents each? Right, so this here should have been just 11. So in other words, we don't want to have this fractional bit here. So how do we change this? Okay. Yep, that's right. You might be thinking of it. We've got to use that math.floor. So let's put that in. I'm going to use floor here because we are working with positive numbers. Okay, so the answer will be 11 point something or other, and I want to pull that downwards to the nearest whole integer. Okay, so that is going to be 11. Alright, so let's run that again, and that did not work for some reason. Okay, let me just pause this for a sec. Hi guys, just walking back. Yeah, as you might have realised, I was putting the math.floor on the wrong thing. Okay, so it'd be the amount that each is getting. Okay, and if yeah, I've put that in here and I've run it. Okay, and as you can see, we are getting the 11, but why the 0.00? Because of this to fix thing. So while that's useful sometimes when we show decimal numbers rounded to two decimal places, in this case it could be a little distracting, so we don't want to have that there. Now what have I left out? I left out the console.log, the finishing bracket. Okay, and let's run that again. Right, so the amount each busker gets is $11. Number of coins left over, okay, that we could either put in the kitty or then divide up into smaller bits like 50 cents or 20 cents or 10 cents bits, okay, is at the moment just 7. Alright, so there's our first one using some different kinds of division. Okay, all good. Right, let's have a look at another problem, this problem 13. In fact, guys, I'm running out of time here, so this is a problem that we might have to actually go over in class, I think, rather than me doing on the video here. So I'm just going to call it short now. Okay, otherwise I'm going to be late for other things. So catch you in class.